Hello everybody, welcome to my channel. Today we have an amazing problem for you guys, where we have a very good one. So let's see what's going on, right? It says top k frequent words, right? So it says given an array of strings, right? An integer k, return the k most frequent strings, right? Okay. Return the answer sorted by the frequency from highest to lowest. Okay, so sort the words with the same frequency by their lexicographical order, right? This is a very good one. Okay. So they're saying that in the problem statement, right? We're given a list of words and we need to return a list of, of the top k most frequent words, right? Frequent meaning the occurrence, how many times they appear in the list of string given, right? We need to return the top k, right? And then we need to sort the words, right? So if two words have the same frequency, right, we need to somehow sort it by their lexicographical order, right? Yeah, so let's see what's going on, right? So the example is going to make it a lot more, you can understand a lot better. So we're given this list of words, right? We see I love LeetCode, I love coding, right? We're all LeetCoders here, we love coding, right? So, and they're asking us to return the top two words in this list, right? And then those are the top two words, guys, because I occurred two times and love occurred two times as well, right? So that's why we return those two, because we need to return the top two, right? Okay. LeetCode only occurred once and coding only occurred once, right? So therefore they won't be included, right? Because because we need to return the top two, so we can only have spot to return two, right? So that's kind of what it is. And this one kind of interesting as well. So the day is sunny, and then we know does definitely going to be one of the top ones because it occurred many different times, right? And then we have is sunny and day, right? So we return pretty much everything, right? Because there are four distinct words in there, right? So they all made it seems like, right? So that's kind of what this is, guys, right? Very interesting problem so far. I mean, you kind of understand, right? So a list of words in a k variable that's gonna tell us to return the top k, right? Most frequent words, right? Okay, very interesting. So how do we go ahead and solve this, guys, right? What kind of sort of algorithm do we need to solve this, right? Okay, we can start with a straightforward solution, right? We always like starting with straightforward ones, right? So what I'm thinking is what we could do, guys, is to somehow do some sort of sorting, right? Right? So what I'm thinking here, right? It's going to be very straightforward. So we know that we need to keep track of the occurrence of each word, right, in the array, right? We need to keep track of the occurrence of that, right? And we could build whatever the structure of choice we end up choosing, right? So I'm thinking we use a map to keep track of the frequency of all the words, right? And then once we have that, right, it's a pretty useful piece of data that we have, because we can easily know the frequency of each word without having to look through the array over and over, right, to find the frequency of the words, right? So data structure is going to allow us to get that frequency of one, right, pretty easily. So once we have that piece of data, right, we can start sorting, right? We could do whatever we want, right? We could sort the words, right? The distinct words, right? Based on some kind of a comparator that we write, right, guys, right? The comparator is going to be very good, right? So the way that's going to be, we're going to sort it based on the frequency, right? And the frequencies in the map, right? So we have that access, right? And we also gonna, so if two words have the same frequency, right, we're gonna sort it by their lexicographical order, right? So the way we're gonna do it, right? So if a word has a right, as a smaller, is lexicographically smaller, right? It'll have more. It'll come before the word that's lexicographically bigger than it, right? So that's how we're sorted. We sort it, prioritize it based on the frequency, and if there's a tie, we essentially do the comparison, check the lexicographical order of the two words, right? Okay, and then once we're done with the sorting, guys, what we do, we return the top k ones, right? From 0 to k minus 1, right, will be the spots that we will return, guys, right? That's what we end up returning it, guys. They're pretty simple. Okay. But as you can tell, right, it wouldn't be too efficient, guys, right? You know, the time complexity would be, you know, not too bad n log n, right? It wouldn't be too bad, or n log n, and it's pretty decent, right? You know, but let's see, can we do a little bit better, right? You know, can we do a bit better? So we're kind of used to this kind of problem, guys, right? We've done similar problems in the past where they're asking us for top k something, right? Top k elements, top k frequent something, right? We kind of familiar with those kind of problems, and we know that they normally you know, categorize into like a kind of a heap problem, right? You know, when you hear the word k, right? You know, so it kind of hints us to kind of use you know, a heap, guys, right? So which heap do we use, right? I mean, main heap, max heap, guys, right? So since they're asking us for the most frequent ones, right? Right? Normally we use the min heap, guys, right? Min heap is gonna allow us to be able to kick out the least frequent word pretty easily, right? Because it's gonna be at the top. Easily have that element at the top, and that's why we end up choosing the main heap as the heap of choice, guys, right? So how it's gonna work, right? It's gonna be pretty simple. We build a hash map, right, to get our frequency, right? And after we build our hash map, what we're gonna do, we're going to essentially start building our heap, right? You know, with also we add elements to the heap, right? And then once we get over a certain limit, right, which is the k thing that we're giving here, right? Once we get past that limit, we kick out the least frequent one, right? You know, and there's a tie, right? You know, we're gonna be kicking it off based on the lexicographical order, right? You know, so an element that's lexicographically bigger will be at the top, guys, right? Because we want we want the ones that are because we need to return it based on the lexicographical order, right? So if an element is lexicographically smaller, then it's gonna stay at the bottom, and all the bigger ones are gonna be at the top if they're all like the same, guys, right? So that's kind of what it is. So for this example, it's given here, guys, you see I love, right? They have the same frequency, right? Say k was 1, right? We need to return the top frequent word in this list of words, right? We will return I, right? So let's say, you know, we add I love in the heap, right? And we have to decide which one to kick out. Since love is lexicographically bigger than I, right? We return it right away, guys, right? We're like, this is the word that we're going to kick out, right? So that's kind of what we're going to do, guys, right? So I think the code will be even more straightforward than the explanation. So let's quickly get into it real quick, guys, right? So what I'm thinking here, we have a map, guys, a map of what? Of strings to integer. Okay. And once we have that, what's next for us is to build our map. Okay, pretty simple so far, right? So we need to look through all the words, right? And then we're gonna put it is all the words here. Okay. Have that getter default, the word 0 plus 1, guys, right? So we build the frequency map, right? So of all the words, right? So that's good to have. And what's next for us is to have our heap now, guys, right? So we know that in Java, RDQ strings, right? It's called a mini heap. Okay. New RDQ. Okay, looks good so far. So what we're gonna do is do a new comparator. Okay. All right, and then we're gonna, you know, build our comparator here, guys, right? And we're gonna be creative with it. Okay, so what we're gonna do is gonna take in 2, string A, string B. Okay, we're looking good so far. Oh, now, so we set that if 2 words are the same, guys, right? If that get, so 2 words have the same frequency, then what we're gonna do, we're going to compare them lexicographically, right? And we do that reverse order, right? So if, you know, B has these lexicographically bigger, right? Then it's gonna be at the top, guys, right? This is what we do here, guys, right? So we just compare them lexicographically, right? That's what we're doing, right? Okay. So we do it in reverse order, guys, right? That's what I'm doing here. Okay. And then if they are, right, if they don't have the same frequency, then what we're going to do, we're simply going to compare them by their frequency, guys, right? Okay. So we compare them by frequency here, right? If not, if they are the same frequency, then we compare them lexicographically, right? And we do it reverse because we want the lexicographically bigger word, right, to be at the top, guys, right? That's what we're doing here, guys, right? Make sure it makes sense to you guys, okay? So after we do that, what's next for us, guys? Right? What's next? So what I'm thinking is we need to look through the lists of through all the words again, right? But we're going to be smart with it, right? We're going to look through all the unique words, right? And we have access to that with the key set, right? So that's what we do have here. And then what we're going to do, we're just going to do a main heap that add we're going to add that word to the heap, guys, right? And if we go over a certain size, right? If the main heap gets too big, okay, and we're gonna take out that smallest one, right? Or if they're all the same, right? We would remove the lexicographically bigger word, right? Out of all the words that are the same, okay? And then after we do that, guys, right, we almost pretty much there, right? So what we're gonna do next is to have our list, right? I think we're almost there, okay? So, all right, new array lists, okay? New array list. Okay, so what we're gonna do now is to loop through all the words, right? So not for loop, but we gotta loop through all the words in the heap, guys, right? Add them one by one. Okay. All right, and then we're going to start adding all the words one by one, guys, right? Into the so heat that poll, take one by one, and we add it to the output result, guys, right? And we can return the result here, guys, but before we do that, let's reverse the order, guys, right? Because we're adding the words because it needs to be sorted from highest, right, to lowest, right? And then we're adding it one by one, right? So remember the least frequent words are at the top, right? So they'll get added first, right? And so that's because of that, right? So let's say we add, right? So all the least frequent will be added first, right? That's why we need to reverse that, so that because the most frequent words will be at the bottom, right? They'll be the last to be taken out the main heap, right? Because that's why we have a main heap, guys, right? They'll be the last, so the most frequent words will be the last ones to be taken out, right? So that's because of that. That's why we have that, guys, right? We have two collections that sort. Right, we're going to sort the results, guys, right? And then we can return the result to our caller. Let's press see if everything's all right. All right, so we build our map. We have our heap, guys, right? We have a custom comparator, right? And we build our main heap. We add every word one by one, and then once we get over a certain size, we kick one out, and then we build output result, guys, right? Let's press run code, see if we pass all the test cases. Oh yeah, my bad. I meant to put reversed. I think things should be straightforward now. Awesome, guys. We're able to pass all the test cases, guys. Or if you guys found value, you guys enjoyed this video, let me know that in the comment section. If you're new here, make sure to subscribe, because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.